Welcome to number 4 in our MQL by request series. Today I'm going to be answering a question which was how to create an expert advisor using a moving average cross. I'm answering this question because I thought it would be a good one to use first now that we've built the framework for our expert advisors. If you don't know anything about the framework that we've been building, I'll put a link on screen back to part 1 of this series where we started to build a framework. There's 3 parts to that, and I'll be using that framework to create most, if not all, of the expert advisors in these by request series. I'll also have a link in the description to the first, second and third parts of the framework, and you can download that framework from our website. There'll also be a link in the description for that. This is the basic structure of the framework. We have an expert advisor template, which is responsible then for creating an instance of our expert object. And the expert advisor will then also create a signal object, an entry and exit signal object, and assign those to the expert object. And the expert advisor is also responsible for creating one or more indicator objects and assigning those to the entry and exit signal objects. Then the expert object includes a trade handler object, and the expert advisor template will then pass the events such as on tick to the expert object, which does all of the work for processing the expert. Since we've built most of that framework already, in fact we've built all of the framework, today we'll need to create a subclass of the entry signal. So there is a CIndicatorBase class. I'll be creating a specific signal for this moving average cross, and I will need to create a class for the moving average indicator, and we'll need to create 2 instances of that, one for the fast indicator and one for the slow indicator. And then we'll just need to use the expert advisor template to create a specific expert advisor for the moving average cross. So this shouldn't be too complicated. I will have to make some adjustments in the indicator because we have to deal with MetaTrader 4 and MetaTrader 5, and indicators work differently, but I'll be explaining those as we go. I'll be building the MT4 part of the indicator first and then adding the MT5 part. So now let's move straight into the code. I'm assuming that you have the framework. If you don't, you should download a copy and then you can use that to follow through this video. I'm going to make one small change to the CignalBase class. If you have seen the earlier installments, I'm storing a list of indicators inside the base class. So the intent is that you know which indicator is used for which purpose and you add them in order, and then the subclass from CignalBase knows which indicator to use depending on the purpose. I'm going to add a method to retrieve a specific indicator from that buffer. So let me just put that in here. So this getIndicatorData method will take an indicator number, which is the index into the array of indicators, and it will take an index which is effectively the bar number inside that. So I'm going to use this method to retrieve data for a specific bar from a given indicator. Let me just create the method below. So now I'm writing the function for getIndicatorData, and I'm going to write this initially in a long form so that I can explain what's happening, and then I'm going to shorten it and leave it in the short form inside the framework. So first I'll just create the function. So that's the function. It returns a double. It's part of CSignalBase called getIndicatorData. It takes an indicator number, which is the position inside the array of indicator structures, and an index, which is the bar number where I'm going to get the value from that indicator. So first I need to get one of the SIndicator item structures from the array of indicators, and that's just addressing it inside the array. I'm returning MIndicatorList, indicator num there. Next I just want to get the indicator object from that structure, and the indicator object is just the indicator element inside the structure, so item.indicator gives me an object of type CIndicatorBase. Then I also need the buffer number applicable to that indicator, and the buffer number is also stored inside the structure, so it's just item.bufferNum. Then I need to get the value from the indicator, and the indicator already has a getData method where you pass in the buffer number and the index, so index is the same as being passed into this function. So all I'm going to do then is call the indicator object, the getData function, passing in the buffer number and the index, and then I can just return that value. To make this shorter, I don't need to assign the value to a variable here. I could just take this and paste it in there. I can also say that I don't need to store buffer number separately. I can just get item.bufferNum and put that there. And the same with indicator. I don't need to store that separately. I can just take item.indicator, put that here. And finally, I don't need to store the item. I can just use this MIndicatorList indicator num, and I can use that where I've used item here and here. And that makes a very compact function to store inside the framework. I'm in the MQL4 editor now, and I've got the include folder open here showing my Orchard frameworks and the framework 1.0 that we've built so far. And I'm going to begin by creating the new signal class. I'm not going to create a specific signal for moving average crossover. The framework is a little bit more flexible than that. I'm just going to create a general purpose crossover signal. And because in the future I might have different types of crossover signals, I'm going to put a folder here inside my signals folder. Let me just create a new folder. And then I'm going to create my crossover signal inside here. And I'm just going to do that by copying this CIndicatorBase and renaming it. All right, now I'll open that and I'll start editing. This is the beginning of my CIndicatorCrossover class. I need to inherit from the CIndicatorBase class. So first thing I'll do is add an include, and then I'll open up my class definitions. So I'm including the CIndicatorBase class, which is one level above. So I'm using relative addressing here with the .. to include the CIndicatorBase class, or the CIndicatorBase include file here. My class is the CSignalCrossover class, public inheritance from CSignalBase. Let me close the class out before I forget about that. Now, as a crossover class, I'm going to be looking for a cross of two different indicators, or two indicators of the same type but with different values. So I need to store both of those indicators. As a crossover class, I'm looking for the values of two indicators, or the same indicator with two different sets of values, to cross over. Typically that's going to involve a cross using bars number 2 and 1, with bar number 0 being the currently open bar. But I want to be a little bit more flexible, so I'm going to create two member variables where I can store the index numbers that let you set the cross, just in case you want to have a longer period between the two where the cross is measured. But the defaults for these are going to be 1 and 2. So these are my two member variables, index 1 and index 2, and normally I'll default index 1 to be value 1 and index 2 will be bar number 2. Next will come my constructors. Constructors are public, and my usual habit, I have one constructor that takes the symbol and the time frame, and then I'll have another that defaults those. So for the constructor that defaults, I'm accepting an index, which as I said is index 1 is going to default to 1 and index 2 is going to default to 2. I'm going to call CSignalBase, which will set the symbol and the time frame being the defaults from the current chart. And then I'm going to call the init method, passing in the index 1 and index 2 values. And the only difference to the other constructor is that here I am accepting a symbol and a time frame being passed in the constructor, and I'm passing both of those to the CSignalBase to set that up. But in most cases, I'll be using the default without the symbol and time frame. And then the init method will simply take the index 1 and index 2. And then I'm including the update signal method. Now this inherits from the parent class, so I'm overriding the parent update signal method, which in the base class does nothing because the base class has no specific activities. and I'm overriding it here because there will be a signal to update in this specific class for the crossover. So now onto the init method, which is very simple. I'm taking the integer values of index 1 and index 2. I'm testing to see whether init result is successful from the parent class initialization, and if not, then I'm just going to return init result. This is a standard line in all of my init methods. And then there's not much to do here. I'm simply storing index 1 and index 2 in their respective variables and then returning init succeeded after that. And then the update signal method. I'm getting the values of the fast indicator and the slow indicator for the two bars. So fast for bar number 1 and fast for bar number 2, or index number 2, slow for index 1 and slow for index 2. And to get the values for these, I'm calling the getIndicatorData method, which is defined in the base class, and I'm passing in the indicator number. So the fast indicator is going to be indicator number 0 when added to the signal class, and the index that I want that value for. And then same indicator, indicator number 0, index number 2. And then for the slow, I'm using indicator number 1, getting the same values for index 1 and index 2. Just leave this comment for a moment. This is a standard test to see if I've had a crossover. So if the fast value is above the slow in the current bar, and in the bar before, if it was not above the slow value, then I've crossed up. And that covers most cases. I prefer to use this method of saying not and then the same condition, because that also covers cases where the two values were the same on the previous bar. And if I have crossed up, then I'm simply saying the entry signal is a signal to buy and the exit signal is a signal to close the sell trades. And then of course the opposite for crossing down. If the fast is now less than slow, and if previously it was not less than slow, then I've crossed down, and so I'm going to enter sell trades and exit buy trades. So, and in case I haven't had a cross, so fast has not moved past the slow line, then I'm simply saying there is nothing to open and nothing to close. Now there is a potential situation where the fast value is above the slow value, has moved down, touched the slow value, and then moved back up again. And this condition will show that as a cross up. It's an unusual condition because that would mean that the fast value in a particular bar has to be equal to the slow value. But this would detect that as a cross up because it would simply say that in the previous bar the fast was not above, and in the current bar it is above, even though the fast had never been below the slow. But it's an unusual case, and I'm just going to ignore it for now rather than make this explanation too complicated. So with that, those are all of the changes in the signal. So I've now created a signal crossover class. Now I need to create a moving average indicator that I can add into the signal crossover. So first I'll create a folder here just to keep things tidy, where I'll be storing any average type indicators that I create. And now I'm just going to create an empty class inside here. Alright, so that's my empty class, which I'm calling IndicatorMA. I need to inherit from the IndicatorBase. So I'm putting the include statement in here, relative addressing, because IndicatorBase is one level above, so .. IndicatorBase. And then my class name, CIndicatorMA, public inheritance from CIndicatorBase. Close that out. Now this is a moving average type indicator, and there are 4 values needed for a moving average: the number of periods, shift, method, and applied price. So I'm storing all of those inside my class here. Then I need the constructors. The first constructor doesn't accept symbol and time frame, the second does. It's the only difference between these two constructors. So this simply takes the periods, method, or periods, shift, method, and applied price, just to fill in these values. And then I'm calling CIndicatorBase, which will give me the default values for symbol and time frame, and then calling the init method, passing in periods, shift, method, and applied price. And this second constructor is the same, but I've added in symbol and time frame, and that calls CIndicatorBase with symbol and time frame, in case I'm running this on something other than the current chart symbol and time frame. But in most cases, I'll be using this constructor. And then of course the destructor, and the implementation of that is below. And then the init method simply takes periods, shift, method, and applied price. And then the getData method. Now there is a getData method in the base class, but I need to override that here. So this is accepting the buffer number and the index. For a moving average, the buffer number is always going to be 0, but we do need the index to know which bar value we want to get back. And the destructor at the moment contains nothing. I'll have to add something when we implement the MQL5 version of this, but for MQL4 I don't need to put anything there. And then the init method, the usual check here to see if the parent class has failed, and then there's nothing more to do than to assign these values of period, shift, method, and applied price. This would be a good place to put some validation, so periods can't be 0 or negative, for example, but at the moment I'm leaving these, and if you do put that validation in, then you can simply use the init methods to return an error code. And then finally the getData method, I'm declaring a value of type double as my return value, and then I'm simply using the IMA function, passing the symbol, which is a member variable, time frame is a member variable, my number of periods, the shift, method, the applied price, and then the index, which is the bar number. And then I just return value. And that's the IndicatorMA class written. Now these two new classes, IndicatorMA and CIndicatorCrossover, I'm putting those inside the framework, but they don't really form part of my base framework. You could keep them under your expert advisor if you really wanted to, but by putting them in here, it means they're useful in other expert advisors. There is one further change then that I need to make to the framework because I've created these inside the framework. I need to update the all signals include file and the all indicators file. And to do that, I'm just going to add another include here. So just adding the IndicatorMA in the all indicators include, and similar for the all signals. I include the crossover / signal crossover include file here. So now the framework includes both of these files. So I've now made minor updates to the framework and created two specific classes that I need. Last thing to do is to create the expert file using the template. So here I've got the EA template MQ4. I'm going to create a new folder inside here. And then I'm going to copy this EA template into the MA crossover and then rename it. Because my template contains almost everything I need, that's much easier than going through the wizard to create a new empty file. Now the template's already bringing in the framework, so that piece of work is done. I do need an input though. I'm using two moving averages here, the fast and the slow moving average, and each of those needs inputs for the period, the method, and the applied price. So the fast moving average here, I'm taking an input for the periods, that's an integer. The method, input fast method, and the applied price, input fast applied price. And I'm just setting the default to 10 periods for the fast period, and I'm using simple moving average here. And then the slow moving average, exactly the same, but I obviously had to rename the variables, and I'm setting that to 20 periods. Now in the template, I've simply got a placeholder here for an indicator. I'm going to replace that and create two variables for the fast and the slow indicator. And note this comment, use the child class name here if you can. So rather than call this CIndicatorBase, I'm actually declaring it as CIndicatorMA, and that is important to be able to call this specific constructor without getting an error message. Now further down, I'm still creating an expert by just creating an instance of CExpert, setting the volume, the trade comment, and the magic number, which I've left at the default values. Here they are. These are inside the template, so if you want to change these, just edit that section. And then set up the indicators. I've got two indicators, so let's replace that. My fast indicator now is a new instance of CIndicatorMA, passing in the fast periods. The shift, which I always set to 0, I've never found a need to do anything else. The fast method and the fast applied price, and then the slow periods, shift, slow method, and slow applied price. So that creates two indicator objects using the same class, but they are different objects because they have different values. Then moving down to the signals, I'm creating my entry signal now as a CSignalCrossover. I'm able to declare entry signal as a CSignalBase because I'm just using the default constructor here, where I'm using a different constructor here to the IndicatorBase constructor, and that's why I declared the fast and slow indicator as a CIndicatorMA. And then I don't want to add the default indicator here. I need to add my fast and the slow indicator, remembering that these are added in order. So once I've added these to the signal crossover, to the entry signal object, this will be indicator number 0 and this will be indicator number 1. And for each of these, it's a moving average, so there is only one buffer, but I'm passing in the buffer number of 0, which is the single buffer for a moving average. Now, I could easily create exit signal being the same as the entry signal, but I'm just not going to use it at all, because my entry signal will have all the same values, so I can just reuse entry signal here. Let me show you. So I'm adding the entry signal, which is my entry signal, and then in the add exit signal, I'll just change that, and I'm adding the entry signal again. It will be the same object, and we've already written the code inside the expert to handle whether this is the same object. And then the rest of the initialization is the same. In the dinit, I don't really need to delete my exit signal because I don't have one, but I'll just replace this line from the template where I was deleting indicator 1, which was the template placeholder. I need to delete the fast indicator and the slow indicator. And then there are no further changes. All of these calls to the expert methods remain the same as in the template. Now I'll just see if I made any mistakes. I'll compile that, and that compiled. Before we go to doing the demonstration though, I will now do the same thing for MT5. So I've now moved to the MQL5 editor, and the main place that we need to make changes is inside this IndicatorMA, because MQL5 handles indicators differently. So the first thing I need to add in MQL5, indicators are assigned an indicator handle. So I will just create one. I don't need to hide this from MQL4, it's just an integer variable, so there's no reason to put compiler conditions around this. And now I've added that handle. In the deconstructor or destructor, I'll need to remove that if this is MQL5. So I'm going to put that inside a compiler condition. So if def MQL5, then as long as the handle is not an invalid handle, I'll call the indicator release method for the handle. And the reason I've put this inside the compile condition is that that function would fail in MQL4. Then in the init method, because I have to assign a handle to the indicator, I'll put another conditional compile in here. So if this is MQL5, then I'm going to call the IMA method and assign that to the handle. So in MQL4, you call the IMA method each time you want to get a value. In MQL5, you call it once to assign a handle, and the arguments are much the same: symbol, time frame, periods, shift, method, and applied price. So the same arguments that would be passed, but rather than returning a specific value from the IMA method in MQL5, we get a handle to the indicator. And then I'm adding a condition here: if the handle is equal to an invalid handle, so something's gone wrong, then I'm going to use the init error method, failed to create an indicator handle, and return init failed. But if that passes, then we'll just drop through to this return init succeeded. And then down to the get data method. In MQL4, I use the IMA method, which gives me a specific value back, but we know that in MQL5, IMA returns a handle to the indicator. So I'll replace that. So I've added a condition around that statement. So if we're in MQL4, then this is the same statement we had earlier, value equals IMA. But if we're in MQL5, I'm going to declare a buffer data array. I'm going to set that as series so that I get back bar number 0 in element number 0 of the buffer data. I'm going to use copy buffer to retrieve values from the handle for the specified buffer number, beginning at index, and because I only want one value back, I'm only asking for one. So this mimics the result that I get back from the IMA method in MQL4. And that value comes back into the buffer data array. And as long as count is greater than 0, I'm only asking for 1. So if count is greater than 0, then my value is just buffer data 0, and then I can return value. And those are the major differences between MQL4 and MQL5 in this framework, and we'll see those repeated in future indicators. There are other techniques rather than having these if-def statements embedded throughout the code. This is not a particularly complex piece of code, and they only appear a small number of times, but I find that they make reading the code difficult. And in future installments, I'll be using different techniques, and you can choose the technique that works best for you. But for now, this is the simple method where I'm simply hiding certain statements. And then the last thing to do is to copy the framework EA for MQL5. We've already copied the MQ4 into MA crossover. I'm going to do the same for MQ5 and the same renaming. So now this is writing the MQ or MT5 crossover, and I'll actually open both of them because the code changes are the same. So I'm simply going to copy my appropriate changes. I'm going to copy the inputs from MQ4. They are the same. I'm going to copy the indicators because now we've handled the difference inside the indicator class. I can copy the indicator creation because that's also the same. And my assignment of entry signals, that is the same. My assignment of signals to the expert is the same. And finally, cleaning up my objects is going to be the same. I'll just check that quickly. So I have no coding errors, that compiles correctly. And now we'll just do a quick demonstration to show you both of these running. In MT4 first, I've loaded the strategy tester. I have placed the 10 period moving average, the blue line on the chart, and the 20 period moving average, the black line on the chart. We can see they're about to cross here. So let me just let this continue. we can see that we entered a sell trade here when the fast line crossed below, and we exited again here where it crossed above, and now we've entered a buy trade. Let me let that continue again. So you can see entering buy trades on a cross up and closing the sell trades. So now let's do the same demonstration on MT5. Now on the MT5 chart, we can see the fast line has just crossed below the slow, and we've entered a sell trade. Let me let that continue a little. And now the fast line's crossed above the slow line. We've closed the sell trade and opened a buy trade. And so that is an example of using the framework to create a moving average crossover. We've done the same thing for both MQ4 and MQ5. We can see that inside the template expert advisor files, the changes were the same. The only consideration we needed to make for MQL4 or MQL5 were these conditional statements inside the indicator and the signals. Now I've created a generic crossover signal. By not making this a specific MA crossover signal, I could pass any values in here. I could pass in 2 moving averages, I could pass a MACD and the MACD signal line, or 2 different MACDs, or 2 different RSIs. So I've created a generic crossover class, and this is the value of using the expert to pass in specific objects to the signal rather than have signals specifically built. So I hope this has been useful to you. Next week I'm planning to add take profit and stop loss to this same expert advisor. It was getting a little long if I added it this week. And those take profit and stop loss, I will do both a simple and a more complex example and show how we can extend the framework even further. So I hope this has been useful to you. If it has, please click the like. If you want to see more videos like this, remember to click subscribe. And if you click the bell icon, you'll actually get a notice next time we release a video. So until next time, thank you for watching.